For this next example on lesson 1.6, example 2a, we're going to use that distributive property that I talked about at the end of the first video. For this example, Darius had $500 to spend at the baseball card convention. He decided to spend all of his money buying rookie cards of his two favorite players. At the end of the season, Darius found that the first card increased in value by 21%, while the second card decreased in value by 7%. He spent D dollars on the first card, so a certain amount of dollars. So he spent 500 minus D dollars on the second, because he had $500 to spend. If he spent D amount, or a certain amount on the first card, then 500 minus that would be what he spent on the second card. So T of D equals 1.21D. That's that 21% for that first card, that increase in value, plus 0.93 times 500 minus D. So that 0.93 is that 7%, because it would be 100% minus 7%, so 93% times 500 minus D, which is the cost of that second card, gives the total value of the two cards. If Darius's cards were worth $550 at the end of the season, how much did he spend on each card? So you can see I typed in the function up there, and then the next line I typed T of D equals $550. In other words, we're going to set that whole function equal to $550 because that's how much his cards were worth by the end of the season. As you can see, I set that whole function equal to 550. Now let's solve for D in that function, because D is the amount of dollars that he spent on the first card, and then we can subtract it from 500 to get the amount of the dollars he spent on the second card. So let's use the distributive property, and we're going to distribute that 0.93 to the 500 and that 0.93 to the minus D. So we have 1.21D plus 0.93 times 500 is 465 minus 0.93D, because we're multiplying 0.93 by D, equals 550. Now let's clean that up a little bit. We can combine like terms. We can combine the 1.21D minus the 0.93D, and we're left with 0.28D plus 465 equals 550. We can subtract 465 on both sides, so we're left with 0.28D equals 85, and then we can divide both sides by 0.28, and D equals 303.57. So that first card cost $303.57. That was the first card. Then to get the second card, we're going to subtract. We said it was 500 minus D, because he had $500 to spend on these cards. So we're going to say 500 minus 303.57, and that equals, he spent 196.43 on the second card. So there are the two answers. How much did he spend on each card? Okay, for example 2b, suppose you just received a $50,000 inheritance. At first, you decide to invest some of the money in a certificate of deposit account that earns 6% and the rest of the money in a savings account that earns 4%. If X dollars are invested at 6%, then E of X equals 0.06X plus 0.04 times 50,000 minus X gives the interest earned in 1 year, though. So that's how much interest you'd make off of that money in 1 year. If you want to earn $2,500 in the first year, how much money should be placed in each account? So you have one account that earns 6% and the other account that earns 4%. Notice with that function, we're going to have to use the distributive property again. So if you noticed, I wrote the function way up here. So we just did that other problem. Now we're working on this one. I'm just using the whole space on the right for that example 2b. So we know that E of X must equal 2,500. That's how much they want to earn in the first year. So we're going to set that entire function equal to 2,500. So we're going to say 0.06x plus 0.04, 50,000 minus x equals 2,500. So now let's solve for that. We're going to do the distributive property, and we're going to distribute that 0.04 to the 50,000 and to the x. So we would have 0.06x plus 50,000 times 0.04 is 2,000 minus 0.04x, because we distributed that 0.04 to the x as well, equals 2,500. Okay, now let's combine like terms. We have a 0.06x and a minus 0.04x. That leaves us with 0.02x plus 2,000 equals 2,500. Let's subtract 2,000 from both sides, so we're left with 0.02x equals 500. Let's divide both sides by 0.02, and x equals 25,000. So in the first account, we're going to have 25,000. We know the second account, it's going to be 50,000 minus x, so it'll be 50,000 minus 25,000. So the second account is going to have 25,000 as well. It just works out that way. That's not always the case. So that's the second account. In this case, the first account has 25,000 and the second has 25,000 as well. Okay, let's talk about clearing fractions in equations. So the last two examples used the distributive property. Now we're going to have to take care of fractions in equations. So often an equation modeling a real situation will involve fractions. If you want to clear an equation of fractions, you're going to multiply each side of the equation by a common multiple of the denominators. You can see I filled in both of those words. So now let's do two examples where we're gonna have to clear fractions. In example 3a, in Game 5 of the 2006 NBA Finals between Miami and Dallas, Dirk Nowitzki, hopefully I said his name right, scored 1/5 of Dallas's points, and Josh Howard scored 1/4 of Dallas's points. The rest of the Dallas Mavericks scored a total of 55 points. How many points did Dallas score? Well, we can say that P equals the total number of points scored by Dallas. So in other words, we're going to say that's all the points scored by Dallas, not just by Dirk or Josh or the rest of the team, but all the points. Okay, so from the problem we can say Dirk equals 1/5 of those points, P, so 1/5 P. Josh scored 1/4 of those points, so 1/4 P. And the rest of the team had said it scored 55 points. So now let's create an equation that has all of that in it. So we can say P equals Dirk, which is 1/5 P, plus Josh, which is 1/4 P, plus 55, which is the rest of the team's scores. Now we're going to solve for P to figure out the total points scored. So notice we have two fractions in there, 1/5 and 1/4, and that's what we're talking about. We need to clear those fractions. So we're going to multiply the entire thing by a common multiple of the denominators. A common multiple of 5 and 4 is 20. So we're going to multiply the entire equation by 20. Not 20x, 20 times. So we can say 20p equals 20 times 1/5 p plus 20 times 1/4 p plus 20 times 55. Let's clean that up a little bit. We can say 20p equals 20 times 1/5 would be 4p plus 20 times 1/4 would be 5p plus 20 times 55 is 1100. There, now we have no fractions in our equation and it makes it much easier. So let's combine like terms. We have 20p, we have 4p plus 5p is 9p, plus 1100. We're going to subtract 9p from both sides. So 20 minus 9 is 11p equals 1100. We're going to divide both sides by 11, and we have p equals 100 points. So the entire Dallas team scored 100 points. If you wanted to figure out how many points Dirk scored, you could take that p equals 100, plug that in for p, and you could say 1/5 of that. Dirk scored 1/5 of 100 is 20 points. Josh scored 1/4 of 100 is 25 points. If you add them all up, it should equal 100. 55 plus 25 plus 20 is 100, and that's the total team score. Let's do example 3b. It's very similar. Okay, in example 3b, suppose during a 2007-08 regular season NBA game involving the Boston Celtics, Kevin Garnett scored 1/3 of Boston's points in the game, and Ray Allen scored 1/4 of the points. The rest of the players scored 60 points. Write an equation to model the situation, then determine how many points Boston scored in this game. So we know that P, once again, is going to equal total points scored by Boston. So we're going to write an equation involving P. Okay, it says that Kevin scored 1/3 of Boston's points. Okay, I wrote that Kevin equals 1/3 P because he scored 1/3 of Boston's points, P. Ray scored 1/4 of Boston's points, P, so 1/4 P. And the rest of the team, it said in there, scored 60 points. Okay, so let's write our equation. P, which is the total points scored by Boston, equals 1/3 P, that's the points scored by Kevin, plus 1/4 P, points scored by Ray, plus 60, the total points scored by the rest of the team. Okay, we have fractions once again, and we want to get rid of those fractions. We don't like dealing with it. So we're going to multiply the fractions by a common multiple. Well, a common multiple of 3 and 4, because that's how we're going to get rid of the fractions, we can multiply it by 12. So we're going to multiply everything by 12. And you got to multiply everything, not just the fractions. So we can say 12p equals 12 times 1/3 p plus 12 times 1/4 p plus 12 times 60. Okay, let's keep going with the math. 12p equals 12 times 1/3 is 4p. 12 times 1/4 is 3p. And 12 times 60 is 720. Let's combine like terms. We have that 4p and the 3p. So we can say 12p equals 7p plus 720. I'm going to move up here next. We can subtract 7p from both sides, so we can say 12p minus 7p is 5p equals 720. We can divide both sides by 5, and we can say p equals 144 points. This is total points scored by Boston. If we want to figure out how much Kevin scored, we can take 1/3 of that because Kevin scored 1/3 of the points. 1/3 of 144, Kevin scored 48 points. Ray scored 1/4 of 144, so he scored 36 points. And the rest of the team was 60 points. If you add all three of those numbers up, it should add up to the 144.